Okay. Hello. Okay. Okay, guys, so let's start. So good afternoon, everybody. So my name is Muhammad Mahmoud. I am the instructor of 3130. Okay. So I sent you an email to tell you, to give you some information about the website of the course. Okay. So if you have not received this email, that means you are not in the my mailing list. So please email me to add you the mailing list. Okay. So this is my information. This is my office number. My website is here, my email. In this course, we're going to have at least 20A, okay? Sam Sylvester, so he's going to be the TA for this one. So Sam mainly will do grading, and also he's going to help you during labs. As you know, we are going to meet in this room every Monday and Wednesday from 4 to 5:15. We're going to have labs on Thursdays from 4:30 to 7:15 in this room. Is that okay? So as I told you, this is the course website is here. If you should have received it in my email, okay? So so you can actually also you can get this website if you just to Google by my name. For example, you can here Google. For example, Tennessee Tech, then my last name. Just I want to show you. So yeah, so you go to my website, you can go to teaching, you can go to undergrad here, and then you can find it here. So 3130, okay. So you can come here, you find. So all the course materials are going to be posted here in this website. Okay. Okay. So all lectures, I'm gonna live stream all my lectures here. Okay, but that doesn't mean I'm allowing you to skip classes. Okay, you know this class is in person, so you should attend in person just in case of emergency. You have COVID or you have contacted someone with COVID or whatever. So you can actually, I want to give you also another way to listen to this lecture online. It's going to be posted here. All lectures are going to be live streamed here. Also, I'm going to record all lectures. I'm going to post them here in this YouTube playlist. Okay, so all lectures are going to be recorded and posted here, just in case if you miss a lecture or if you miss something in the lecture, or you want to listen to a lecture again and so on. Okay. I have office hours on Mondays and Wednesdays from 1:30 to 2:30. And again, at any time, if you need help, don't wait the office hours. Just email me and I reply to the email. Okay. So here I want to talk about the prerequisite for this course and what I'm going to teach in this course. Okay. For sure, in this course, one of the prerequisite, I'm expecting that you know something about digital systems, right? So you know binary numbers. I'm going to do very quick revision, but I'm expecting that you know how to convert between different numbers. Also, you should know some programming concepts. So I don't want to teach you for loops. You should know what for loops means, okay? But I'm going to teach how can you make for loops using assembly, okay? But at least you understand the concepts of programming, like how to make loops, why you need loops, and so on. Okay? So in this course, there will be 5 chapters. In the first chapter, I'm going to talk about microprocessor architecture. So this chapter is somehow general, okay, for any microprocessor. What should be architecture? So I'm going to teach you some concepts, some new concepts, okay, for you, because I'm going to use this concept in the remaining chapters. After that, after that, I'm going to, in chapter 2, I'm going to teach assembly language. I have been teaching this course for several years, but this year I decided to change. I'm not going to change the content, so I'm going to teach exactly the same thing, but I changed the processor. Okay, so I used to teach SC S12, and I'm going to tell you why I decided to go for ARM processor. Okay, so this year I'm going to teach ARM processor. Okay? In chapter 3, I'm going to talk about interfacing to a microprocessor. Okay, if you have input-output devices, how can you program them? How can you read data from input device? How can you write data to output device? In chapter 4, I'm going to talk about interrupts. Finally, I'm going to talk about timer functions and pulse width modulation. This is what, after you finish this course, this is what you should learn in this course. Number 1, you should learn some concepts about the computer architecture. Okay, so you are going to get some idea how computers work. Okay, how they work, how programs are executed by the hardware. Okay, so you will understand it better. So also the internal organization of typical microcontroller. Also, I'm going to teach how can you program a microcontroller using assembly and C. So the course are going to have both assembly and C. Okay. I'm going to talk about how can you interface a microcontroller to input-output device. I'm going to talk about interrupts. What are interrupts? Why they are interesting? How can you program them? How can you use them? Okay. Also, I'm going to talk about timer functions. Okay. Here, you will see by yourself in this course. Again, as I said, I'm going to teach assembly and C language. You will see by yourself the difference between assembly and C language. You know, assembly is low-level programming language, low level. Okay. So every instruction, as you will see, every instruction you write in assembly actually is going to be run by the hardware. The hardware will do it, right? In C language, all the instruction you have in C language are not going to run by the hardware. This is your own language. This is not the hardware language. The hardware doesn't understand what for means, doesn't understand what while means. This is your own language. That's why you need a translator to translate the high-level programming language like the instructions used in C language to translate to assembly, because assembly is the language of the hardware, right? Every instruction in assembly is executed by the hardware. There is a hardware circuit is going to execute it, okay? So I don't want to spend too much time because I'm going to talk about this one later, but in general, you will notice that assembly, because every instruction you write is going to be done by the hardware, is going to be detailed. There are a lot of details, okay? You have the code, usually the code is too long, right? Because every simple thing, you have to do it by yourself, by the hardware. But high-level programming language, like C language, why it's called high level? Because it's far from the hardware, okay? So maybe you are going to write, as I'm going to teach in details later, maybe you are going to write one instruction in C language, but this instruction, after... Hello? Okay. So maybe you are going to write one instruction in C language, but the compiler is going to translate, because we agree now, the hardware doesn't understand your own language. The hardware doesn't understand Java, doesn't understand all of that, right? So there should be a translator to translate to the hardware, because any program has to be done by the hardware eventually, right? So anyway, so what I'm saying is that maybe one instruction in C language is going to be translated to 10, 20, 30, 40 instructions in assembly. Okay, that's why in short, number 1, C language, you write less number of lines, less number of code in C language, right? But the hardware is hidden from you. You don't know anything. Just if you want to do something, use this instruction. How it works by the hardware, you have no idea. Anyway, so I'm going to give you, so the conclusion, I'm going to give you more details later, guys, but the conclusion is, I want you to understand it's important to learn both of them. Why I'm saying that? Because some students think, yeah, programming using C language is easy, so why we have to learn assembly? Okay, I'm going to tell you later why you need to use assembly. Quickly, for two reasons. Number one, assembly, without assembly, there is no way to understand how processors work, right? Because the details are hidden. C language is going to hide the details from you. Just if you want to do something, just use this one. How this one is going to be done, the hardware, you don't know. But in assembly, you are going to write every details, right? So there is no way to understand how processors work if you don't learn assembly. That's number one. Number two, still some people, especially if you want to do, if your application is very time sensitive, you want to do something very quickly, right? Or you want to do something like very efficient. You don't need to take much space in the memory, or you want to do something programmed to run it very fast, right? Because every microsecond is important. For example, in some applications, right? In this case, what usually the people are doing, they program it using assembly, because assembly programs usually are much more efficient than the C language. Why? Because as I'm gonna teach later, compilers are not smart enough. Compilers, so let me make it this way. I want to do something. If I do it in assembly, maybe I need this amount of code. But if I do it in C, maybe it's gonna take much more. So more code means, number one, more time. Number two, more space in the memory. You got what I'm saying? That's why, again, if you want to do something, if you want to program something quickly, for sure, C language is easier, right? Because a lot of details are hidden. If you want to understand how processors work, it has to be assembly also. If you want to do something, a program that's you want to do it very fast, okay? So assembly is the best choice. Also, if you don't want to take too much resources, too much RAM or short code, assembly. Okay. Anyway, so the conclusion here, I want to tell you both of them are important. I can say that's why I'm going to teach both of them. Okay. So you have here, this is mostly I'm going to use this textbook for the purpose of this course. You may not need to buy the book. Okay. So the slides are going to be detailed enough to understand this course. Okay. This is how I'm going to evaluate this course. Number one, we have homework. So this, maybe we're going to have several assignments. So 10% of the final grade. We're going to have a project. This project is going to be 15% of the final grade. Usually I ask a student to work in the project. In every project, usually 2 students are going to do one project. Okay, as one team, 2 students. If you want to do it individually, I'm okay. In some cases, if you have if you want to do something big and you can justify to me that 3, 4, 5 students want to join in one project, I'm totally fine. Why not? But you need to justify. But normally 2 students can work on one project. Okay. For sure, as I'm going to tell you later, if you wanna, I want to encourage you to do good projects, because I believe students can learn better when they work on a project. Okay, that's why for several years I decided to give students 5% bonus if you do a good project. Okay, and I posted a good project online. Maybe I'm going to show you some of them. So I encourage you to do good projects so that you can learn better. And if you do good one, I can give you 5%. This 5% on top of the total. You got what I'm saying? On top of the total. So it's a big deal if you do good project. We're gonna have labs, okay? We're gonna have labs. So these labs are gonna be 20% of the final grade. These labs are gonna be on Thursdays. It's gonna be here. Again, in labs, usually you work also in groups. Usually in labs, usually 2 students are gonna work together in one team. If you want to work individually, I'm totally fine. But I think this is gonna be easy. It's easier for you if you can have a team, so that you can. I don't know what happened. I don't know what's going on. Anyway. So what I'm saying, if you can work together, you can save time, you can learn from each other, you can share the work, you can work together. Okay, so I think it's a good idea to do that. So when the time comes, I'm going to give you more details about the labs. We're going to have quizzes, right? It's going to be 15% of the final grade. We're going to have two tests, 15%, and the final exam is going to be 25%. Any questions here? So at least you can work with another student in one group in two things, in labs and in project. You are not allowed to work in groups in homework, quizzes, test, final exam. It's not going to be in groups, okay? Any questions? Okay. The good thing is all exams, all quizzes are open book. So you can bring the slides, okay? You can use the slides in, only hard copies are allowed. Is that okay? So you can print the slides, you can use the slides. Why I'm doing this way? Because I don't want you to worry about it, or I don't want to worry about you need to memorize instructions. Okay. I want you to only focus on if you already have the material, if you already have the instructions, can you use them to solve the problems or not? This is more important. What benefits you are going to gain if I ask you to remember 100, 200 assembly instructions? You get what I'm saying? So everything is going to be open book. What I really care about is giving up. If I give you a problem and you already have the material, can use the material to solve this problem or not? So all quizzes, all exams are going to be open book, including final exam. Okay. For sure. I'm expecting any work you have to do, you have to be neat and it has to be legible. Okay. For sure, every instructor has to tell you any form of academic misconduct is not tolerated. I want to repeat it again. For homework, especially because I found, because in labs and project, you can work in a group. So some students think they can do the same for homework. No, homework has to be done individually. Same thing for quizzes, tests, and finally. Okay. Any questions? Again, guys, I sent you an email. If you didn't receive my email, that means you are not in my mailing list. So please email me to add you to the mailing list. Okay? Because I'm going to use emails to communicate with you all the time. Anyway, so also here I give you some advice here. If you want to do well in this course, what you have to do, you have to attend for sure lectures, labs. Participation in the classes here, you have to pay attention. It's a good idea to print the slides and you can take some notes. Okay. One more thing, important thing is that in my advice to you is not all the quizzes, not all labs, not all assignments have the same weight. Okay. That means maybe one lab needs more work than other lab. So this lab is going to be graded out of 40, but this lab out of 60. You got what I'm saying? So you have to be careful about this. Same thing for homework. So they are not the same weight. Okay, it depends on how much work you have to do. Okay. So just if you need any help, I'm here. This is my job, right? So that's what I'm doing for a living. I'm here to help you. Okay. So please don't be shy. It's bad to be shy. When you need help, you just email me and I can see how I can help you. Is that okay? Okay. Anyway, any questions? One more thing, as I told you in the email, all the PDF files posted online have a password. So I can't tell you the password right now, but I already emailed you the password. Okay. So this password, you need to open the file. So every time you open the file, it's going to ask you to enter this password. If you hate that, for sure, so every time you open the same file, you need to enter the password. If you hate that, you can cancel it. Okay. The way you can cancel it, that's what I'm telling you. After you open it in the first time, you can cancel the password so that after that you can open it on your machine without the password again. So I'm telling you here what you have to do. Okay. But you need, so what you have to do here, you have to select the file and then properties, and then you have to select here security, and then you select here no security. So if you do that, you can cancel the password. However, you may not have this option in some versions of Adobe Acrobat. Okay, so that's what some student told me. So you have to make sure you have the right Adobe Acrobat. Okay, otherwise you may not have this option. Here, all course videos, the videos of this course, including the lectures, I'm gonna post them here. Here I give you some. I told you here about some. I really encourage students to do good projects, and I think that good projects are really very important to learn. To learn anything, to learn things better. So here, I put here some of what the students have done before in this course. I give you some very interesting videos here in good project, as I told you. However, as I told you, this year we are going to change the processor. So what we did before, we used to have this board, the board you see here, but this year we are going to change the processor. So maybe I'm going to go through one or two couple of them quickly. For example, this one.
Manufacturing automation was simple.
Again, we're not going to use this port this year, okay? Because I changed the processor. So I'm using this port to communicate using Bluetooth, communicate with this car, and this car should solve the maze somehow. It has to find a way to exit it. So anyway, so maybe I don't want to spend much time, but you can see here other projects. For example, here you can control the arm of a robot using the microcontroller. Yeah, as you see here. So here he's controlling it using his smartphone, because no smartphone is going to communicate with the board, okay, using Bluetooth or Wi-Fi, whatever, usually Bluetooth. Anyway, other really very good projects. So I really encourage you to, after you learn this course, do your best to do such good projects. Okay. So anyway, any questions? Okay. So now I'm gonna start the chapter 1. So as you see here in this chapter, guys, number one, I'm going to talk about data representation. Here, I'm going to make a very quick revision about hexadecimal, binary, decimal. How can you convert between them? All of that. Okay. Hopefully, I can do it very fast because you should already have taken things like that before. After that, I'm going to talk about computer hardware organization, memory system operation, how memory works, why we need memory. Okay. Then I'm going to talk about the processor. Then I'm going to talk about how can we execute programs. So all from number 1 to 5 are general. So general stuff for any processor. Starting from number 6 here, I'm going to focus on our ARM processor. Okay. So let's start with the first one, data representation. Okay. So all of you know, all of you know that we have different systems for numbers, different types, different systems, right? So here, so all of you are familiar with binary numbers, right? You are familiar with hexadecimal numbers and decimal numbers. And we have other systems. But I'm going to focus only on these 3 systems. I'm going to tell you why. You know, in binary numbers, we have 2 digits, 0 or 1. And using 0 or 1, I can represent any number using just a set or a bunch of zeros and one. Any number I can represent, like zeros, so 1 0 1 0 whatever. So here I can represent any number this way. Okay. For hexadecimal, we have numbers from 0 to 9, and then we have 10, which is A. A means 10. Okay. So these are the digits I'm gonna use to represent any number. So we have from A to F. Okay. So any number can be represented using these digits. For example, the number can be 3A F2, whatever. Okay. So any number I can represent it this way. That's what we call hexadecimal. Okay. Here is it binary. Binary means 2. Yes, because we have two digits. Hexadecimal means 16. Yes, because we have 16 digits here, right? From 0 to F. F 10 mean A means 10, right? So we have here A, B, C, D, E, F, right? So 10, 11, 12 until 15, right? And you start from 0, so we have 16. We have 16 digits here. Any number I can represent it using these 16 digits, right? For sure, decimal, that's what we are using in our life, right? So this one has number from 0 to 9. Okay, so that's what we are using in our daily life. Is that okay? So now I wanna. So let's tell you number one, why we need binary number in this course. Why? Very simple. The answer is very simple. Computers, hardware, processors can only work with binary numbers. That's it. So this is the language of hardware or processors. Is that okay? So this is mainly for processor or for the computer system, and so on. So what do you mean? I mean, any data you store in memory has to be in binary. I mean, any instruction, it has to be in binary. Everything has to be in binary. All the operation you are doing, if you want to do multiplication, addition, whatever you want to do, okay, by the hardware is going to be in binary. That's why. So who's going to use binary? The hardware, and that's what you are going to see in this course. So everything you will see is binary. Okay. For decimal, who's using decimal? Decimal is used but only for humans. So this is only for us. Okay. Again, computers don't know decimal, right? So this is just for us, right? So for humans. Okay. So that means after you get the output from the processor, you are gonna get the output in binary, right? But for example, I'm gonna get something like that: 1 1 1 1 1 1 1. Okay. But if I want to display it to the human, to the user, I cannot display it 1 1 1 1 1 because this is not our language. We don't use this language, right? That's why you have to convert. You have to write a program here, and then when I want to display it to the user, I have to display 255. This is my language, right? That's exactly what we're going to do. So we need some kind of translators. Microprocessor is going to give you binary numbers, right? Humans can only understand this. That's why you need to write a program to convert, right? So, and the opposite also is true. If you get a number from the user, you are going to get number in binary, right? Sorry, in decimal. So you have to convert it to binary before you give it to the processor. We agree on that, right? So let's agree that processor can only understand binary. We just use decimal because this is our language, or this is the numbers we are using, right? That's what we understand. Okay, that's okay. So this is for human. This is for the machine. That's okay. So who is using this one? Hexadecimal. Okay, actually, no one is using hexadecimal. However, we are going to use it because it's just hexadecimal is shorter representation for the binary. Just for human. So what I want to say is that if I tell you, for example, this is a memory location. Okay, which one is easier for you? If I want to tell you in this location, I'm going to store 10 10 10 10 11 It's very hard for us to. It's not convenient for us to use it, right? Instead, I'm going to tell you in this location, in this memory location, I'm storing the number 3A, for example. Okay, because 3A is more convenient to us, but that doesn't mean the hardware is going to store 3A in hexadecimal. It doesn't mean that. Again, we agree the hardware is going to only store it in binary, right? But when I want to give you a binary number, it's more convenient for us to give you in hexadecimal instead of binary. Why? Because in hexadecimal, every digit here in hexadecimal is gonna equivalent to 4 digits in binary. That's why it is shorter. Okay. So again, conclusion before I give you more details. The conclusion is in this course, we are gonna focus on 3 systems. One, this is the hardware can only do this one. Period. So even if I tell you, in this memory location, we store this number in hexadecimal or decimal, I don't mean it's going to be in decimal, okay? But I'm telling you it's going to be equivalent to this one, but in binary. Let's agree on this. Only hardware can only understand binary numbers, okay? We're going to use hexadecimal numbers because, as I told you, just a shorter representation, right? So it's easier for us. Instead of giving you a binary number, I'm going to give it to you in hexadecimal, just shorter representation. But technically, hardware doesn't use it. Technically, humans don't use it. But instead, it's just more convenient to me to give you a number in hexadecimal than binary. Okay. So anyway, so here. So as you know here, guys, every digit here is equivalent to 4 digits in binary. Okay. So for example, 0 is equivalent to 0, 0, 0 binary, right? 1 hexadecimal is equivalent to 0, 0, 1. Okay. 2 here is equivalent to 0, 0, 1, 0, right? All the way until F. F is 1, 1, 1, 1. Okay. So this one means 15. Okay. For sure, you know how can you convert binary to decimal, okay? So what you have to do here, you know how you are telling us this one is 15. Yes, how did you know this is 15? Okay, you know how to do the conversion. I'm going to say it quickly. So the way you have to do it is, if you have 1, 1, 1, 1, this is 2 to the power 0. To the weight of this bit is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay, so if you add, so the way you have to do it, 2 to the power 0 times 1 plus 2 to the same 1 plus times 1 plus 2 to the power 2 times 1 plus 2 to the power 3 plus times 1. Okay, so you have to multiply this number by the weight. Okay, the total should equal to 15. Same thing here. So this number is number 1. Why? Because you only have 1 here, right? This one is number 2 because the 1 is here. So here you are going to multiply 0 times 2 to the power 0, okay, which is 0, right? Plus 1 times 2 to the power 1, plus 0 times 2 to the power 2, plus 0, 2 to the power 3. For sure, you don't need to multiply by 0, but okay. Anyway, so this is 1 is equivalent to. I think that's easy, right? So if you have a binary number, you can convert it to a decimal, okay? So now what I'm going to explain quickly now, how can you convert, if you have a hexadecimal number, how can you convert it to binary, okay? And also how can you do the opposite? If you have a binary number, how can you convert it to hexadecimal? Okay, I'm going to tell you. For example, if I have this number, 3AF2, for example, okay? So this number is hexadecimal. I'm telling you, this number is in hexadecimal. So how many bits we have here? How many bits? Very easy. Every digit should be 4 bits. So total, we have here 16 bits. Is that always? Yes, it is always. Always any digit in hexadecimal is equivalent to 4 bits in binary. Is that okay? So the way you have to do this one, guys, very simple. So here, every digit here, you have to replace it with 4 bits. 4 bits. The 4 bits that are equivalent to this number. For example, 3 is actually 0, 0, 1, 1. That's okay? Okay. A is 10. A means 10, right? So 10 here means this is 8, 2, 1, 0, 1, 0. Is that okay? Because this one is 8. This one, 2 to the power 3. This one is 4, 2, and 1. Okay? So this is 10. F is actually 1, 1, 1, 1. 2 is actually 0, 1, 1, sorry, 0, 0. Okay. So this is how, very easy, very simple. This is how can you convert hexadecimal to binary. Is that okay? So just replace every digit by the four binary numbers here. Is that okay? So again, you can see which number you can see here why you are going to use hexadecimal, because again, shorter representation is more convenient for us, right? So if I tell you 3A52, is that easier for you, or just if I tell you 0011101011110010, right? You understand what I'm saying? So anyway, so that's why you are going to use hexadecimal, because it's just more convenient for us. So now it's very easy. If you want to convert between hexadecimal to binary, just replace every number with 4 bits. Okay. Now, what if I want to do the opposite? So I have a binary number, and I want to convert from binary to hexadecimal. How I can do it? Very simple. Number one, you have to start from right to left. Okay. You have to make group of 4. You have to make groups of 4. So these 4 together, these 4 together, these 4 together, and at the end, for example, you have only 2 bits. Okay, you can add zeros to make it 4. Zeros are not going to make a difference. You got what I'm saying? So number one, you have to start from right to left. You have to divide into groups of 4, right? So we have here 4, 4, 4, and then after you make groups of 4, you can replace every 4 by its digit. You got what I'm saying? Every 4 are equivalent to one digit. As I told you, we have here 0, 0, 0, 0 are equivalent to hexadecimal 0. 1, 0, 0, 0 are equivalent to hexadecimal 1. All the way until 1, 1, 1, okay, they are equivalent to F. So all what you have to do, just to see what is the group, and then replace it by the digit here. Is that okay? So if I do that, this number is 2. This number is F. This number is A. This number is 2. Sorry, 3. Okay, guys. Any questions? Okay. Again, I'm going to say it again, guys. What's going to happen is, I'm repeating it again because I want you to understand it. When I tell you this memory location is storing F2, okay, I'm giving you the number in hexadecimal because it's just better for us, more convenient for us. That's it. But practically, or in reality, it is stored in binary. You understand what I'm saying? So I'm gonna do it all the time. So when I tell you this is a machine code for this instruction, I'm gonna give you in hexadecimal, but you have to understand it is actually stored in binary. But it's just more convenient for us to work on hexadecimal than working on binary. Binary is really too hard. 0, 1, 0, 1 is too many, right? So here, every digit are equivalent to 4. Okay. Any questions? Okay. The other thing also here, guys, if I tell you, for example, the number is 1, 0, okay, or if I tell you I have 1, 0 apples in my office. So how many apples I have? Okay. For sure, you should not answer you because the question is not clear. Why the question is not clear? Because 1, 0, it can mean 2, it can mean 16, okay? It can mean 10, right? 16, it can mean 16. So you have to tell me which system you are using, right? So 1, 0 is actually 2 if you are using binary numbers, if the number is binary, because the 1, 0 can be any one of them, right? But for example, if you have 3A, so still you have to tell me, but 3A, it is hexadecimal because A is hexadecimal, but still also, so the question is that if I give you a number, how can you know what is the system of this number? This is not something you can guess. You have to tell me, yes. That's why you are going to use a prefix. So we are going to use a prefix. Okay, so what kind of prefix we are going to use? Okay, so this prefix is going to tell what is the system of this number. Okay, what type of this number. Okay, for what we are going to use here in this course, 0x. So if I put 0x, 1, 0. So if you see 0x in the beginning, that means this number is hexadecimal, right? We're going to use 0b for binary. So if 0b, for example, 1, 0, and then you can put the number after that. So 0b in the beginning here means this number is in binary. we are going to use 0x for hexadecimal. If there is no prefix like 10 this way, that means it is decimals. By the way, different programs, different assemblers, or different compilers may use different symbols for prefix, for the prefix. So before we used a dollar sign. So by the way, if in the slides, if you see a dollar sign, so that's what we used before in the other compiler. We used a dollar sign to tell this is hexadecimal. Here we used a percent. Anyway, it's not a big deal. It depends on the compiler itself, right? So for our compiler, we are going to use 0x to tell that this number is in hexadecimal, 0b for binary, and nothing. You are going to put here nothing if it is in decimal number. Is that okay? Again, this is not something you can guess. You have to tell me what this number is. Is that okay? The other thing also I want to teach here, guys. You remember in C language, you had to define the type of the variable, right? You did something like integer. You did something like long. You did something like short, unsigned integer. You remember something like that? So you have different types. Okay. So why we have different types for data, for our data? Why we have different types? Simply because every type can tell you, number one, the size of your data. You got what I'm saying? So for example, long is gonna store bigger number than integer, right? Because why? Because every type, every one of them is gonna reserve certain numbers in memory. You got what I'm saying? So I'm gonna give you more details now. For example, in some compilers, integer means 16 bits, right? So that means your number, I'm gonna reserve 16 bit for your variable, right? And they told you there is a limit, a certain limit, okay? Because in 16 bit there is a certain limit. And they told you in C language, if your variable needs a bigger number, you have to use long, because long can store a bigger number. You understand what I'm saying? So anyway, I'm gonna do the same thing like right now in assembly. So you should understand we have different types. Every type can tell you how big space or how big the number you can store. There is a limit for sure. Okay, I'm gonna give you more details now on this one. Also, it can tell you, if you remember, for the integer, they told you this is used for signed numbers. That means your number can be signed numbers, and this one is used for unsigned numbers. Is that okay? So before I give you the details, the conclusion is we have different types of data, okay? Different types. Every type can tell you if this number signed or unsigned, okay? It also can tell you if that space, how big is the space, okay? And then it's up to you to select. For example, I am measuring something, and I'm not expecting that the biggest value I'm gonna measure is not gonna exceed, for example, 1 million. Okay, so I'm gonna book a certain space that's enough for 1 million. If you need more, so you should have a bigger space that can be enough for. Okay, so I'm gonna give you now more details about this one. How can we do something similar to this one in assembly here? So as you see here, guys, number one, so your data can be a bit, can only 1 bit. Okay, your information, your data can be only 1 bit, right? So every bit can store either 0 or 1, just 1 bit, right? Or your data can be a byte, So byte means 8 bit together. 8 bit together is making a byte. You got what I'm saying? So this is one piece of data, 1 byte, one piece of data. This data can be the temperature, it can be the velocity, it can be speed, whatever, but it's just one variable, okay? So also we have half word. Half word here is 16 bits. Okay, so let's agree on this one. So we have byte, we have half word, we have a word which is 32 bits. Also we have double word, which is 64 bits, right? So for sure, as you will understand, as I'm going to explain shortly, as we go this way, as bigger than number, right? I can store a bigger number. You got what I'm saying? So anyway, so now from now on, I assume when I say byte or I say a word or half word, you understand what I'm saying. Is that okay? So again, byte means 8 bits, half word is 16, a word is 32 bits, and when I say double word is 64 bits. Any questions? Okay, guys? Okay. So again, this is just how big is the data you can store. For sure, I can store here much more data than this one. I'm gonna give you more details, okay? But just by common sense, okay? Also, we wanna agree on when I tell you the least significant bit, what do you mean? When I tell you the most significant bit, what it means? We need to agree on this one. So in the future, when I use these terms, you should understand what I'm saying, okay? So for example, here, this one, guys, we have 8 bit. So the first bit here from at the right-hand side, we call it bit number 0 until bit number 7. You understand what I'm saying? So we start from the right-hand side, we number them, bit number 0, bit number 1, bit number 2, until bit number 7. So bit number 0 here, this bit, we call it the least significant bit. Bit number 7, we call it the most significant bit. Is that okay? So why? Why this one is the least significant? Okay, if you think about the English word, least significant. Yeah, because this one has the lowest, the smallest weight, right? As I told you, this bit, the weight of this one 220, 221 until 227. That's why this one is called most significant, because this one has more weight. Is that okay? So the same thing, if my number is 16 bit, it's the same thing. So this bit here, this bit, the first bit here is called the least significant bit. Also, this bit is the most significant. It's the same thing if we are talking about a word. It's the same thing if you are talking about double word. Is that okay, guys? So let's agree on that. Number one, for any whatever the type you are using, we number the bits from right to left. We start from 0, bit number 0, bit number 1, bit number 2, bit number 3 until the last one here. Okay. And also, let's agree, the first bit here is called the least significant bit. And the last one here, the most significant bit. Okay, guys? So in the future, if I say the least significant, I'm not going to tell you where is the least significant. I assume you already know what's the least significant. The most significant, you should know what I mean by most significant. Is that okay? One more thing sometimes we do, look here, guys. This half word. This half word here, it has 2 bytes, as you see here, 1 byte and 1 byte, right? Because it has 6, 8 and 8, right? 8 bits and 8 bits. Sometimes we call the first byte here, we call it the least significant byte. And this one, we call it the most significant byte. Okay, guys. So also we should be familiar with these terms. So if I have half a word and I tell you the least significant byte, so I mean this 8 bits. When I tell you the most significant byte, so I mean this one, okay? Same thing for a word, right? So for a word, we have half word here and half word here, right? 16 and 16. So also I can say least significant half word and most significant half word. Is that okay? So I can split into 2, least significant. Anyway, also here, you should be familiar with these things for sure. Like kilobyte means 2 to the power 10 bytes, which is equivalent to this one. Megabyte is 2 to the power 20, which is equal to this number of bytes. When I say gigabyte means 2 to the power 30, which is equivalent to this one. Any questions? Okay, guys. Okay, so now I told you guys we have different types here. Okay, so every type here should store like a certain size of data. Okay, so what I now I want to talk about something else. It's about, as I told you, we have signed or unsigned numbers. Okay, so that's what I'm going to explain now. So numbers, guys. So any number can be unsigned or it can be signed, or number, or any quantity, anything you are measuring, it can be, or any variable can be signed or unsigned. Is that okay, guys? For example, if I want to count how many students we have here in the classroom, is this a signed number or unsigned number? It's unsigned numbers, right? Because you can tell from the English name, unsigned numbers, it means it can be 0 or positive. It cannot be negative, right? So this number is storing, this number is storing either 0 or positive, but this one is storing, it can be positive, it can be 0, it can be negative. Is that okay? Again, which one I have to use, signed or unsigned? Very simple. It depends on what you are measuring. If I'm counting the number of students, for sure, this cannot be negative, right? So this is unsigned, right? But if I measure the temperature can be positive, can be negative. Okay, so it depends what you are measuring. Anyway, so in case of numbers, you can be signed or unsigned. Is that okay, guys? In case of unsigned numbers here, in case of unsigned number, guys, if I have in-bit number, okay, that means this in-bit numbers, they can store numbers from 0 until 2 to the power n minus 1. Okay, so what is n? Very simple. In case of a byte, so n is 8. In case of half a word, so n is 16, and so on, right? So in general, for any n-bit number, I can represent the numbers from 0 until 2 to the power n minus 1. That okay? But in case of signed numbers, it can go from negative. It can go from, if you have in-bit numbers, okay, so it can go from negative 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. This is the range. This is the range of numbers I can represent in in-bit number if this number is signed, right? So you can see here, we have one more negative number, right? So because this is 2 to the power n minus 1, this is 2 to the power n minus 1, but minus 1. You got what I'm saying? I'm going to give you more details so you'll understand better, but this is the range for any bit number. For sure, the bigger n, the bigger the number I can store. Is that okay? So I wanna yeah, so here, what I want to show here, guys, if you see here, yeah. So here, again, as I told you, in case of unsigned numbers, okay, I told you the range can be from 0 until 2 to the power n minus 1. Okay, this is the range. That is why, in case of a byte, we're going to go to from 0 until 2 to the power 8 minus 1. That means if you are using a byte, I can store a number from 0 until 255. Okay, so 0 actually is equivalent to 0, 0, 0, 0, 0, 0, 0. This is a byte, right? 255 is equivalent to 1, 1, 1, 1, 1, 1, 1, 1. Okay, so we have all these numbers starting from 8 zeros until 8 ones. This is your range from 0 until 255. Is that okay? How many numbers we have in total? So how many numbers we have in total? Actually, the total numbers we have 2 to the power n. So if I have in-bit number, how many total numbers I have? 2 to the power n, right? So here, in case of, for example, in case of binary, we have here 8 zeros. I started from 8 zeros all the way until 8 ones. How many numbers we have here? 2 to the power n, which is 256. 256. So to have 256 numbers, the first one is 0, the last one is 255. Is that okay? Yeah. So in general, if you have n-bit number, that means you can represent up to 2 to the power n different numbers. Okay. In general, for case of unsigned numbers, I'm gonna start from 0 until 2 to the power n minus 1. And I give you the numbers here for different n. So in case of a byte, n is 8. That's why we go from 0 until 2 to the power 8 minus 1, which is 255. In case of 16, so you can go from 0 until 2 to the power 16 minus 1, which this is the maximum number you can represent in half word. This is the maximum. If your number is unsigned, so I can't store more than 255. This is the maximum, right? There is a limit, right? So this one 65, 535. In case of a word, again, word means 32 bits. This is the range you can have, okay, for billion, right? So, and in case of double word, for sure, we are gonna have a bigger number. Any questions? So conclusion. Number one, for any bit numbers, in total, how many numbers we can have? 2 to the power n. This all the space, all the total numbers we have. In case of unsigned number, we're going to start from 0 until 2 to the power n minus 1. Okay. Now, what about in case of signed numbers? I'm going to repeat the same slide right now, but I'm going to talk about signed numbers. Okay, for signed numbers, still, how many numbers we have is still 2 to the power n. Yeah, because this all the different combination. If you have n bits, all different combination 2 to the power n. But the difference now, what I did in the unsigned, I used the whole space in the positive side, right? But now I'm gonna split the space. Half of the space in the positive side, half of the space is gonna be in the negative side, right? That's what I'm telling you. That's why this one is gonna, but I cannot split it exactly half, right? Because we have 0. That's why negative is one more, right? So if you can see here, guys, so if your number is signed, so that means you can store numbers from negative 2 to the power minus 1 until 2 to the power n minus 1 minus 1. So you always have one negative more. You will see right now. So for example, give you example. If you have a byte, so now n is equal to 8. So that means I can store negative 128 until positive 128. This is a limit. You cannot store more. If your number is bigger than that, don't use a byte, use a word. Or use half word. Use something bigger, right? So anyway, same thing here for half a word. This is the limit for and all of them using the same formula. In case of signed word, this is the limit, okay, and so on. Any questions? Okay, so still 2 to the power n for both of them, but here, remember, for unsigned, so this is the limit here, but for unsigned, it was from 0 until 255. You got what I'm saying? Here, it's only until 127, right? Because half of the space went to the negative side here. So if you see how many numbers we have from here to here, it's going to be 256. How many numbers we have from here to here in case of unsigned is still 256, because it's still the same space, right? But anyway, any questions? Okay. Now I want to talk about signed numbers. If your number is signed, how we can represent? So if in binary, if your number is signed, so it can be positive or it can be negative, right? So what we do in decimal is, for example, you can say positive 9, you can say negative 9. To do the same thing in binary, how can I know if this number is positive or negative in binary? We don't have positive or negative in binary, right? So it has to be ones and zeros. So how can we do it? Okay, so actually there are different systems to represent. There are different ways to represent negative numbers in binary. There are different ways. Okay, I'm not going to explain all of them. I'm going to only focus on what we need, or what most of, or all processors are using. So the system we are going to use to represent the negative number is called the two's complement. Two's complement. So the two's complement is the system we are using to represent negative numbers. Okay, guys. So what this means, I'm going to tell you what it means. Okay, so for example, if you have a byte this way, 0 0 0 0 1 1 1 1. Okay, if I have a byte this way, okay, this number is positive 15. Is that okay? Positive 15. Is that okay? So how can I calculate negative 15? Negative 15. Okay, all what you have to do, very simple. You have this positive 15. All what you have to do, calculate the two's complement of this number. Calculate the two's complement. Two's complement is equivalent to, it's like you multiply it by -1. Two's complement, when you calculate the two's complement of a number, so actually you multiply this number by -1. Let's see. So, okay, make it simple. I'm going to make it simple. So I have 15. This is 15, right? It's very easy. Anybody can make this 15, okay? So how can you calculate negative 15? In order to calculate the negative 15, all what I'm saying, calculate the two's complement of 15. That's it. Make first, write 15, and then calculate the two's complement of 15, okay? Okay, but how can I calculate the two's complement? Okay, there are different ways, but the very easy way, actually, the two's complement is the one's complement plus 1. So now, listen to me. There is something called one's complement. If you add 1 to the one's complement, you are going to get the two's complement. Okay, make it simple. Okay, I'm going to make it simple. Look here, guys. We have this number here. Can you calculate the one's complement of this number? One's complement. Okay. Yes. And one's complement, you just flip the bits. Flip the bits, that's it. And this is the one's complement. So this number is going to be 0 0 0 0 1 1 1 1. Okay. So after I calculate the one's complement of this number, I'm going to get this one. Okay. So now let's agree on this, guys. At any time when I tell you one's complement, you should understand one's complement means you are going to flip the bits. That's it. Okay. Then if you add 1 to the one's complement, the result is going to be the two's complement. Okay. So if I add 1 here, it's going to be 1 0 0 0 1 1 1 1. This one. Okay, guys. So if this number is 15 and I calculate the two's complement, this number has to be negative 15. If I have negative 15 and I calculate the two's complement for negative 15, I'm going to get 15. You get what I'm saying? So very simple. Number one, you should know what do you mean by two's complement. Two's complement means if you have a number, how can you calculate the two's complement of the number? Number one, you have to calculate the one's complement, which is easy. Just flip the bits, add 1. This is how you can calculate the two's complement. Okay? You should understand what two's complement means. Two's complement means you are going to multiply this number by negative 1. So if this number is negative 7, you calculate the two's complement, you are going to get positive 7. If your number is positive 7, you calculate the two's complement, you are going to get negative 7. Is that okay? So I think in one quiz, I'm going to ask you, can you please calculate negative 5? Or give me the binary number for negative 5. Again, there are different ways, but the easy way, how can you do it? Number one, get positive 5 first. So positive 5 is 1 0 0 1 0 0 0. Is that okay? So this is a byte. In this byte, I'm storing number 5. Is that okay? This is number 5. Sorry, no, yeah, okay. This is 9. Okay, now, oops, yeah. So yeah, so this is number 5. Okay, and then if you calculate the two's complement of this one, you are gonna get negative 5. So this is positive 5. When you calculate the two's complement, you are gonna get negative 5. So how can you number 1 flip the bits 0 1 0 1 1, 1, 1, 1, and then add 1. So it's going to be 1, 1, 0, 1, 1, 1, 1. Okay, so this one is negative 5. Negative 5. And if you calculate the 2's complement of this one, you are going to get this one. Okay, guys, any questions? Again, if you have a number, I am expecting now you can calculate the 1's complement of this number. Is that okay? So when I tell you at any time calculate the 1's complement, you know how to do it. Just flip the bits. Also, you know how to calculate the 2's complement. 1's complement plus 1. Also, you should know what it means when you calculate the 2's complement. What it means, you actually multiply the number by negative 5. So if this number is 5, I calculate the 2's complement, I'm going to get minus 5. If it is minus 5, you calculate the 2's complement, you are going to come to negative 5. Is that okay, guys? So this is the approach we are going to use to represent the negative numbers using the 2's complement. I told you there are different approaches, okay, to make negative number in binary. But why most of the microprocessors are using 2's complement instead of the other approaches? Because, very simple, because it can make the hardware efficient. Why it can make the hardware efficient, as you will see later, because using the same hardware, I can do addition and I can do subtraction, as you will see later. Okay, so here that's why the people, or most of, if not all the processors, are using this one instead of other things. Okay, by the way, one of the ways to make a negative number is the 1's complement. Okay, so 1's complement alone is one of the ways. But again, in this course or in all processors, we are using the 2's complement to represent the negative numbers. Okay. So now, okay, now we agree there are numbers can be unsigned or unsigned or signed, right? So here numbers can be unsigned or it can be signed. Now I'm gonna explain. If I give you a number and I ask you a binary number and I ask you to convert it to decimal, how can you do that, right? But it's easy. Sometimes it's not straightforward. So let me explain what I want to say. For example, if I tell you the number is unsigned, again, unsigned, there is no sign. It's always positive or 0. Okay? So for example, if I give you a number like this one, 0, 0, 0, 0, 1, 1, 1, 1. Okay. Again, as this very easy case. All what you have to do, guys, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so on. All what you have to do, you have to multiply every bit by its weight plus this bit weight. So here, this one should be 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 should for sure zeros. I'm not going to count it because 0 times anything is 0. So this one should be 15. Very simple. So if I give you a number and this number is unsigned and you want to convert it to decimal, this is the traditional way: 2 to the power 0, 2 to the power 1, 2 to the power 2. That's it. Any questions? Okay. Now, if I give you a number and I tell you this number is signed, if I tell you this number is signed, now there are two cases, two different cases. The first case is the number positive or is the number is negative. Okay. How I can know if the number is, if I give you a number and you want to know if this number is positive or negative, how can you know? Okay. Very simple. Who's going to tell you? The most significant bit is going to tell you. Okay. So here, if you have a number, this bit, the most significant bit, is going to tell you if this number is positive or negative, right? So if the most significant bit is 0, so this is a positive number. If the most significant bit is 1, so this is a negative number. Is that okay? Very easy. So all what you have to do, the most significant bit is going to tell you if it's positive or negative. That's it, right? Number 2, if your number is positive and I want to convert it to decimal, okay, so very easy. I can use the same approach like this one. For example, so it can be the same number like this one. For example, 0, 0, 0, 1, 1, 1. So, and this number is signed. Okay, so all what you have to do, look at this one. Yeah, this is a positive number. So if it is a positive number, So it could be, I'm going to use the same way like unsigned, 2 to the power 0 to the normal way, okay? So if the number is negative, for example, I have a number like this one, 1, 1, 1, 1, 1, 1, 1. Okay? So if I have a number like this one, and this number is negative. Why? Because the most significant bit here is 1. It's a negative number. Okay? How can I convert this number to decimal? Okay, guys? So look here. Again, there are different ways to do it, but I'm going to tell you, in my opinion, what is the easy way. Okay, in my opinion, but there are different ways. So again, this number is actually negative x. I am okay. So I need to find x. What is x, right? I am sure this number is negative, but negative something, right? So all what I can do is I can calculate the 2's complement of this one. If I can calculate the 2's complement of this one, I'm going to get positive x. Because I told you the 2's complement, you are going to multiply by a negative 1. If you have a number, and I calculate. So actually what I did, I'm going to get the positive version of this number. By calculating the 2's complement, I'm going to get the positive version of this number. So let's do it. So if if this number, again, this number is negative x, and I want to find x. I want to know what is x, okay? So I'm going to get the positive version of this number. So what I'm going to do, 1's complement, I'm going to flip all the bits, it's 1's complement, then I'm going to add 1. Okay. So if I do that, it's going to be number 1. So if I calculate the 2's complement of this one, I'm going to get 1. If I calculate the 2's complement of 1, I'm going to get this one. So what is this number? Negative 1. You got what I'm saying? Because these numbers are the same, but this is negative, this is positive. Is that okay? This is the easy way to do it. So let me summarize what I said. Number 1, if your number is unsigned and you want to convert to decimal, this is the straightforward way. 2 to the power 0, 2 to the power 1, 2 to the power 2. Right? If your number is signed and positive, so you are going to do the same way like this one. But if your number is signed and it is negative, again, there are different ways, but the easy way, you can just get the positive version of this number, positive version. Once I get the positive version, so now you become here, so I can use the same approach like this one. You got what I'm saying? Okay. So let me tell you something important now. So you are, wait a second, I got confused. Okay. Why you are confused? I'm confused because if I have a number like this one, 1, 1, 1, 1, 1, 1, 1, 1, okay? If you tell me this number is unsigned, please don't tell me negative, it's unsigned, okay? So how can you calculate the decimal out of this one? I told you, all what you have to do, guys, is 2 to the power 0, 2 to the power 1, 2 to the power 2, until 2 to the power 8. If you add everything together, you are going to get 255. Yeah, so this number is 255. That's true. That's true. Again, if it is unsigned, 2 to the power 0. Don't think about anything. 2 to the power 0, 2 to the power 1, 2 to the power 2, and that's add everything together. Is that okay? Okay, now, if I tell you this number is signed, right? So because it is signed, as I told you right now, I'm going to calculate the 2's complement of this one. If you calculate the 2's complement, I'm going to get 1. So this is positive 1, so this one should be negative 1. Is that okay? Okay, guys? Okay. And how? Because this number is negative, right? So because when I look at this bit, I found it's 1, right? I'm going to calculate the 2's complement only if it is negative, right? So how can you know it is negative or positive? From the most significant bit here, it is 1, right? It's a negative number. Okay. So just calculate the 2's complement, I'm going to get 1. Okay, guys? I'm confusing you. Why? Because I'm telling you now is that this number here, it can be 255 or it can be negative 1. Is that okay? But I didn't tell you how can you know if this number is signed or unsigned. What I told you, if this number is signed, you can know if it is positive or negative. If I tell you the number is signed, you can know if this number is positive or negative. How? From most significant bit. But if I give you a number, I didn't tell you. If you give you a number, how can you know if this number is signed or unsigned? Because it has completely different meaning, right? If it is unsigned, it's going to be 255. If it is signed, it's going to be -1. Okay, guys? Okay. So how can you know? Is there something I can look here at the bits and see if it's signed or unsigned? The answer is no. Is no. This is not so. This is something you have to consider in your program. No one can know if these numbers are signed or unsigned. Processor cannot know that. This is something you have to consider when you write your own program, right? Because if this number is signed or unsigned, that means, okay, so let me put it in a different way so that you can understand better. Look here, guys. I told you, if I want to display this number to the user, I have to convert it to decimal, right? Because humans don't use binary numbers. Okay, by this way, we're going to have two programs. I'm going to have a program for unsigned numbers. This program, when it takes this number, is going to give me 255. I'm going to have another program for signed numbers. When it takes this one, it's going to give you -1. So I'm going to have two different programs, right? When you write your program, you have to decide from the very beginning. This number is signed, this number is unsigned, this number is signed, this number is unsigned. And then you have to use this program or that program. Same thing as I'm going to teach later. We have some instruction that are used for signed numbers. Some instructions are used for unsigned numbers. I'm going to teach later. So you are the programmer. So when you write your program, you know, you decide from the very beginning, this number is signed, this number is unsigned. And then you have to use the correct instruction. So conclusion, if I have numbers this way, there is no way I can't tell. If you tell me this number is signed or unsigned, I don't know. This is something you have to consider as a programmer in your program, right? So as I told you, give you here, as I'm going to teach later, we have instruction for signed number, instruction for unsigned number. So when you write your program, if your number is unsigned, so you have to use the unsigned instruction. If your numbers are signed, you have to use the signed instruction. So this is something you have to consider as a programmer when you write your own program. Is that okay, guys? I give you another example. If you want to convert a binary to decimal, we're going to have two programs. One for unsigned numbers, so that when it takes a number like this one, it's going to give me 255. We have another program for signed number, so that when it takes numbers like this one, it's going to give me -1. So when you write your program, you decide from the very beginning in your program, yeah, this number is signed, so I have to use this program, or this number is unsigned, I have to use this program. I know this part is a little bit confused to students. I'm making it very clear. Signed or unsigned, there's something you have to consider when you write your program, writing your program, right? Any questions? Okay, so we're going to meet on Wednesday.